So far we spent a lot of time talking about petroleum resources, but there's two other fossil fuels, coal and natural gas. So let's spend a little bit of time talking about those. In this lecture, we're going to focus on coal and coal resources. Okay. So the United States has more coal than any other country. It's about 80% of our U.S. fossil fuel reserves, which is over a 200-year supply. Right now it supplies about 23% of energy needs, mainly electrical power production, right? Because we're not shoveling coal into the gas tanks of our vehicles or airplanes. The total U.S. resource for this is about 3 trillion tons. Since about 1900 in the United States, right, the time of the first industrial revolution, coal has been used to generate electricity. Right now in the United States, coal use is actually down because hydraulic fracturing has made natural gas less expensive, and because natural gas burns cleaner than coal. In terms of the fossil fuels, it is better for the environment and air quality. So if we look at global recoverable coal in 2011, as we can see, the United States has a lot more coal reserves than any other country. Russia also has significant ones, as does China. In China, there was a period of time in the early 2000s where more than one coal-burning power plant was being added every single week during China's phase of massive industrialization. Okay. If we look at major coal producers, so even though the United States has more coal than China, China is producing more coal than the United States. And as we see, between 2000 and 2011, China's production of coal almost tripled. And that's because China is a country that between 2000 and 2011 was in a massive phase of industrialization. During that same period of time, the United States was developing the fracking industry so that we used more natural gas to generate electricity and less coal, so our coal consumption has remained fairly level. Other developing countries like India have started producing more coal, again because they are a country who has been rapidly industrializing during this period of time. European Union countries like Germany, which is down further on the list, have seen their coal production go down because they have become more aware of the environmental issues associated with coal production, coal mining, and also combusting coal to generate electricity. So they've been looking at other cleaner energy resources. Okay. So again, if we look at major coal consumers, so China is the biggest. As we said, China in the early 2000s is a country that is massively industrializing, and they are looking for energy resources in any possible way that they can get them, be it petroleum, coal, natural gas, or renewable resources. In the United States, coal consumption has gone down because hydraulic fracturing has made natural gas less expensive, and with environmental concerns, natural gas burns cleaner than coal does. As we saw before, it's gone up in India because, like China, they are industrializing, and it's gone down in European Union countries because they have become more concerned with the environmental impacts of using coal to generate electricity. In Japan, the rate of coal production, interestingly, has gone up because after the Fukushima nuclear disaster, Japan wanted to start using less nuclear energy, but Japan does not have any oil resources of its own, so they started using more coal. Okay. So this tells us a number of things. China and India are rapidly industrializing. They are looking for energy in every single form possible. This is significant because they're the two most populous countries globally. In the United States, coal has stagnated because natural gas costs less and it burns cleaner. Western European countries are using less coal because of its negative environmental impacts. Russia is using more because, again, they're looking for inexpensive domestic energy. Now, Russia, because of fracking and the ability to drill for oil in Siberia and the Arctic, is also exporting petroleum and natural gas resources in addition to coal. Right. So in the United States, there's three major areas of coal production. The first and oldest of these is the Appalachian region, so the eastern region, which consists of Pennsylvania, Kentucky, West Virginia, and over into Ohio. So traditionally, this is the original home of coal production in the United States. And in the Appalachian area, traditional coal production has been by underground mining. There are some oil reserves in the Midwestern area, Illinois, Iowa, Kansas. They're not as big and they're not used as much on as much of a scale as the Appalachian reserves. More recently, because of the Clean Air Act of 1973, coal production has now been shifted to the Western Rocky Mountain area. So Wyoming right now is the biggest coal producing state in the country. Montana has coal reserves, as does North Dakota. Noting, of course, that all of these states are areas with a lot of fracking for natural gas and petroleum reserves. The reason that we've shifted to the Western Rocky Mountain oil is because of the Clean Air Act of 1973. So coal has different grades and quality. The Appalachian coal is a lower quality, so the energy content per pound is not as high, and the coal there is very high in sulfur. And when you combust coal that has sulfur in it, the combustion process makes SOx, so sulfur dioxide, sulfur trioxide. SOx reacts with water vapor in the atmosphere to produce sulfuric acid, which then falls back to the earth as acid precipitation. So as acid precipitation and other air pollution became of greater concern with the Clean Air Act in 1973, coal producers were looking at finding cleaner sources of coal to burn. So they moved towards the Western Rocky Mountain coal, which is much higher quality, which means higher energy content and lower sulfur content. This move has improved the air quality associated with coal combustion, although the notion of clean air associated with coal combustion is still a bit of an oxymoron. But what it did at the same time was completely devastated the economy of Appalachia, so that the Appalachian region in the United States is among the poorest region in the United States. And they've got a lot of health and social problems associated with those high poverty levels because the number of coal jobs that people always relied on are just not there anymore. On the other hand, it strengthened Wyoming's economy. So anytime an industry shifts from one region of a country or the world to another, the region that it leaves is often going to be left with economic devastation. The region that it moves to will often see economic growth. Okay. Now, coal mining is a very labor-intensive, dangerous process. So outside of being a soldier in an active combat zone, the most dangerous job in the world right now is being a coal miner in China. In the Appalachian region, as in China, coal has been extracted via underground mining. So tunnels are dug very, very deep into the earth to get down to the coal seams, and coal miners go down into those tunnels. I think we've all seen movies and pictures and videos of this, and physically mine for the coal. It's a very labor-intensive process, and it's a very dangerous job because the tunnels can collapse. There can be a buildup of gases underground, like methane, that are toxic for people to breathe. So even up into the 2000s in the United States, people are still dying in the coal industry because of the dangers associated with underground mining. Now, to get at more surface deposits of coal, strip mining has become more popular. So in Appalachia, strip mining has been introduced, and in the Western Rocky Mountain coal, strip mining has been introduced. So this is a safer process for humans because it's less labor intensive. So you don't have people dying, laborers dying as a result of underground tunnels collapsing. But it's environmentally a very devastating process because what happens first is the overburden. So if you're talking about, Rocky Mountain coal or Appalachian coal, these are both mountain ranges. So the mountaintop is removed, usually via explosions. Once you explode away enough of the overburden, the top of the mountain, to get to where the coal is removed with large equipment. There's attempts to replace the overburden once the coal has been extracted, but I think you can imagine ever restoring an area back to its original form is just not possible. The process of doing this clearly creates great erosion losses on land. So you get severe rainstorms or snow melt on these mountaintops where the coal has been extracted, and soils and the coal dust and residues run off, and where they wind up running to is the rivers and streams that are in the valley areas of mountains. So you can get a huge amount of water pollution from coal mining runoff. Okay. So some of the environmental impacts of mining, especially strip mining, leads to huge amounts of land destruction. Revegetating or trying to ever restore a mountain to its original form once you've blown the top off of it is really impossible to do. So animal and plant ecosystems are destroyed by the strip mining process. Water supplies in mining areas are very contaminated. So you get acid mine drainage into rivers, which can be devastating to fish and other aquatic life in a river system. Human water supplies are ruined by this, and a lot of fish and aquatic species are just killed off because they cannot live in water that is acidified or highly polluted. Okay. Some of the other environmental impacts associated with coal combustion. Coal combustion emits more CO2 than any other fossil fuel, so it's a big contributor to global climate change. When you have more CO2 in the atmosphere, some of that CO2 enters the oceans and reacts with water in the oceans to make carbonic acid. So the pH level, or the acidity in global oceans, has been rising over the last century. And this is causing devastating loss of highly sensitive coral reefs and other ocean ecosystems. As I said, CO2, NOx, because when you combust coal, you're burning it with air, which contains nitrogen. So if you burn air, you're going to make NO2, NO3, also known as NOx. SOx in particular reacts with water vapor in the air to make sulfuric acid. To a lesser degree, CO2 and NOx make carbonic and nitric acid, which travels by air currents. So a coal-burning power plant has the giant stack where the combustion byproducts are being released into the air. Wind blows them long distances downstream. In that process, they react with water vapor to make these acids and then fall either as rain or snow in areas that can be hundreds, if not 1,000 miles downstream of the source. When water bodies are acidified, the acid actually burns the gills of the fish, and since fish breathe through their gills, they suffocate. It damages the eggs that the fish lay, so it harms fish reproduction. It kills aquatic plants, which of course is what the smallest fish eat. So entire aquatic ecosystems are destroyed by acid precipitation. Acidity also reacts with the limestone that statues are made out of. So limestone statues globally have been severely damaged, if not destroyed, by acid rain. It damages trees and plants in the same way that if you drop acid on your skin, it's going to burn your skin. Acid will burn the leaf structure of plants. It also leaches metals from soils. And then those metals run off into bodies of water at levels that can be toxic to aquatic organisms or toxic to terrestrial trees and plants. Okay. All right. So some of the health impacts of coal. If you are a coal miner and you're working in Appalachia in an underground mine, most likely you're going to die of lung cancer or emphysema. There's no way to do underground coal mining without being exposed to very small particulate matter of coal that lodges in the lungs and leads to lung disease. Coal ash from burning coal has radioactive elements, but also heavy metals like lead and mercury that wind up in water supplies, are consumed or taken up by aquatic plants, which are eaten by fish, and then these things bioaccumulate in the fatty tissue of fish. When humans then eat that fish, it bioaccumulates in our fatty tissues at high enough levels to cause neurological damage to people. Okay? If you live or work near a coal-burning power plant, you're more likely to suffer from heart damage, lung damage, central nervous system damage, and even brain damage from lead and mercury poisoning. So even though the United States has a vast abundance of coal reserves, in terms of human health and environmental health, it really is not the best energy source that we can be using. Okay. Now, recently, in about probably the last at least 4 presidential elections that we've been through, some of our politicians have touted the concept of clean coal. They're mainly saying this because if you want to win the vote of the Appalachian states and other states that are big producers of coal, you cannot talk about eliminating the coal industry to save the environment, because the people who rely on the coal industry for jobs are not going to vote for you. So politicians like to talk about clean coal. Now, in some ways, because of the Clean Air Act, it is required in the United States to remove SOx from stack gases to reduce acid precipitation. So this is done by a process called flue gas desulfurization. So the SOx is removed before the gases leave the power plant. So that's a good thing, because the impacts of acid precipitation in the United States have gone down dramatically since we've introduced this technology. That being said, though, CO2 is still emitted from coal combustion, and it is the chief climate change gas. NOx is still emitted. It also contributes to acid precipitation and photochemical smog that we'll talk about in our next unit when we talk more about the environmental impacts. Lead, mercury, and heavy metals are still emitted. So coal combustion may not be contributing greatly to acid rain anymore, but it's still contributing to all these other negative impacts that would really make it a good idea if we moved away from coal, even though the United States has an abundance of it. So we'll leave off there for today, and we'll come back and we'll talk about natural gas resources as the last fossil fuel next.